So here's what we got going for today. We're going to do this lab 2.3.3.5, where we're going to have a single PCA connected to a switch. And where last time we just looked at a couple of switches and did some show commands. We didn't do any configuration on it much. This time we're going to actually configure the switch so it can be a telnet server, and you can tell it into it from your workstation. So that's lab 2.3.3.5. That's located right there in the and this is what the lab looks like. Now, before I do that, I want to again point out this exciting Texas Network Academy Career Fair webinar that's going to take place on April the 15th. This is going to be a free webinar that you can Zoom into. It's actually going to be Cisco's version of Zoom, WebEx. This is a great opportunity for CCNA students. There's a big demand in the Dallas-Fort Worth area for CCNA skilled, CCNA certified individuals, even early career people. Hiring managers are looking for these guys. So we're going to have 5 hiring employers that are going to be present at this seminar. City and Red River and Computer Discount Warehouse and Presidio. There's going to be people there talking about the job market. What should you do to be better prepared to get in the job market? So that'll be a free webinar. To register for that, after you click on the Texas NetAcad Career Fair, in the bottommost section of the My TCC Blackboard link for this class, open that link and then click on that Cisco WebEx link, and it'll take you to where you can get started and register at WebEx, and you'll get an email invite where you can go and attend this course. It's going to be great. You should be there. Okay, let's see now. Okay, so let's start doing the lab. Now, I'm going to do this first as a demonstration of how to get started in this in Packet Tracer using the cool new Packet Tracer physical mode feature. And then I'll switch to my actual real devices here, and I'll do the lab actually on a real VMware PCA, like you guys who are here person to person in the lab would do with the connected to a real switch, a Cisco 2960 switch. Okay, so Packet Tracer, here you go. Here's Packet Tracer. This lab is a great example of the new physical mode, which allows you to see both the front and the back of the real switch. So if you guys here in the lab notice on the real switch here, we've got a real switch. The console connection is in the back. That may be a little roller cable that plugs into the back. That's how you make your initial console connection. You have to plug in the console first before you can do anything. It doesn't have any IP addresses. It's an erased clean factory fresh switch. And then on the front, we have my PCA is plugged in port number 6 on the front. Is how it shows on the diagram for this. So let's see how we would set this up in Packet Tracer, and then I'll step there and actually do this on the real equipment, because in Packet Tracer it's going to be quite similar. Okay, so physical mode, we're going to go to the physical mode switch here at top and click physical. And then I'm going to go down and I'm going to open up this home city, open up the corporate office, and open up the main wiring closet. And I'm going to add up here these tooltips. If you hang your mouse on it for a second, let this sit for a second. They're not labeled very well, but the tooltip comes down and says create a new rack. I want a rack, and I want a disk. Okay, I need a switch and a PC. So I'll get a switch first. I'll click down in the lower portion here and click on the switch and choose the 2960 switch. And I'm going to drag it down to where it's closer to where the PC is going to be, so I can magnify it and you can see it more easily later. Then I'm going to click on the end devices and just choose a regular PC and jump it up here. And let me see now if I can expand this and make this easier to see. I think I made it a little bit too big. Make it a little smaller. Okay, so there's our switch. And I'm going to go ahead and go in and correct this in Packet Tracer on the config thing. The switch is supposed to be S1. And the PC is supposed to be PC-A. Now they're labeled correctly. Let me pop back over to the logical view just 1 second, and I'm going to arrange it so it looks like on the front page of the lab, which shows the PC connected to the switch like this. And let's go ahead and make our physical connection on the physical end. I like the physical end here because it's more intuitive. You can see the wires draping and swooping as they go around from one point to the other. So we have two connections we need to do here. Let me do the Ethernet connection first, which is easy to see on the front page of it. I'll click on my jagged lightning bolt, and I'll choose a standard Ethernet cable, copper straight through standard Ethernet cable, and I'm going to connect it to port number 6. I think it says port number 6. That's our standard. Yeah, port number 6. We're going to connect it to port number 6, and I'm going to connect that to the Ethernet port on the PC. And here we have our drooping cable. Okay, now I need to connect the crossover cable, the baby blue crossover cable. I mean, not the rollover cable, and it's on here on the front of the PC, the RS-232 COM1 port, what the most guys call it. But I need to plug it onto the back of the switch. So I'm going to click on the switch and say, let's look at the back of the switch. And there's the console plug right there. So now it's connected. We take a view of that back of the switch. We see there's a wire plugged into the console port. And it comes down kind of underneath the switch here and connects to that port, connects to that RS-232 COM1 port that's present on the PC. And then we can go and configure it. Now, let me show you one gotcha here in Packet Tracer. I want to be able to get to the equivalent of, in the real machines here in the lab, we're going to use a VMware, and we're going to use PC-A, and we're going to use the TerraTerm program, the real physical TerraTerm program, to go through our real wires that go here to the back of the room. You guys that are doing this on Packet Tracer, what you're going to do is click on the desktop. And to make that commit, there's two options here. You can do it this way. You can click on the desktop and choose the terminal program. And click OK. And there, I'm connected to the switch. I can proceed with the configuration of the switch. The other option in Packet Tracer is you can simply click on the switch and click on the CLI, and you've got the same CLI, and you can connect to it. The other gotcha is when you configure the IP address, the required IP address on the workstation, it's real similar to the Windows. In Packet Tracer, you're going to click on the PC, click on the desktop, then click on this top left one IP configuration, and you'll put in the proper IP address. I'll illustrate this: 192.168.1.10. Press the tab key, and we don't need a default gateway because this lab has no router, just within the PC and the switch. Okay, so that's the wonderful Packet Tracer, how you would do it there. Now I'm going to switch to the real physical stuff here, as we would do it here with actual standard equipment. So the first thing I'm going to do is fire up TerraTerm. Recording, we're rolling. Okay, good. Mic on. Now, as a reminder, you will always run TerraTerm. When you guys that are here presently, physically in the room, SBS 1125 at the South Campus of Tarrant County College, you will always run your TerraTerm program from the Windows 10 host operating system, not within the VM. TerraTerm is installed within the VM. You might run TerraTerm within VM in today's lab to make it be a telnet client, for example. He actually typed telnet from the command line, but TerraTerm can also be a telnet client and a secure shell client. So I fired up the actual real physical actual operating TerraTerm from the Windows host machine. I'm going to click the serial radio button, and I'm going to change it to, oh, I'm already connected. Wait a minute. Hold on, I'm already connected. I can't connect twice. Let me kill TerraTerm. I'm going to stop TerraTerm entirely and restart it entirely. You're allowed to run 2 copies of TerraTerm on your Windows desktop PC host operating system. One goes to COM1, typically S1R1. One goes to COM4. That'll be your second connection that will go back to a second device. So you can do 2 switches or 2 routers, so 1 router and 1 switch. And later on, in the later classes, when we get really busy, we have 2 routers and 2 switches. You'll just log into the workstation next to you with the X, and you'll use it as well. Okay, so I'm going to start TerraTerm. And by default, it's COM1 because I didn't have it already running. I had it already running there earlier. I forgot about that. Click OK. Press the Enter key. I've got a switch. For purposes of this looking nicer on the screen, I'm going to go and increase the size of the font. Increase it to 14 and drag this up here a little bit. Now, when you first reload a switch, or you first apply power to a switch and it comes up, it's going to go to that Do you want to go into the automatic configuration setup, which you always say no to? If the switch has been on for an hour, like these switches have been, you'll just see switch. So how do we reassure ourselves that this switch is truly erased completely? What are the two things we must do on a switch if it has a previous configuration on it to make sure that it won't interfere with this lab that we're doing? Like, the advanced Cisco guys might have done something to the switch and it has a previous configuration on it. Okay, so the first thing I'm going to check for is I'm going to go to the privilege exec mode, and I'm going to type the dir command. I could also type show flash, which would work just as well. And I'm looking for the presence of a file called vlan.dat. That's a database if you've created any extra VLANs on this switch. Out of the box, it's all one broadcast domain. We haven't talked about VLANs yet. That'll be in the class that comes up in the fall. Just make sure there's no vlan.dat there. If it were there, you would type the command delete vlan.dat and press enter 3 times, and that would get rid of it. You only have to do that on switches. You don't have to do that on routers. The other command that we use, which is the same command on a switch or a router to make sure the startup configuration doesn't exist, I'm going to type the command show me, is there an existing startup configuration present on this device? No, it's not there. If it had been there, I would have typed erase start and then typed the reload command to reboot the switch, wait 3 minutes for the reboot, and we'd be ready to go to the lab. Well, we're ready to do it now. Everything's erased. So I always like to not staple the first page of the lab together so that I can see the IP addresses very clearly up here. So we're going to cable the network. Well, the network has been cabled for you. You'll just we're going to establish a console connection to the switch from PCA. The network connection and the console connection has already been established for you at each one of your student workstations, because for some reason they won't allow you to put your grubby grimies on the wires right now. They're scared of the virus or something. So let's configure basic switch settings. I'm near the top of page 2, and I'm going to connect to the switch. And he says that I'm supposed to do some things here. First of all, I'm supposed to go to the privilege exec mode. I did that. I'm at the privilege exec mode. Now let's give it a meaningful host name. First thing we should always do, give it a meaningful host name so that if you got 2 switches, you don't get mixed up which switch is which switch. So I'll go to the global configuration mode and I'll say host name S1. Then let's set the password for getting from the user exec mode to the privilege exec mode. Enable secret class. Shows up as clear text when I type it in. Notice that now when I do a show run. Enable secret command encrypts the password on the screen so that no one can look over your shoulder, or if you have a printout of a configuration of the devices, which you might if you're a network technician engineer responsible for maintaining all these devices, you want to make sure that you have a printout so you can restore it if the switch, say if the switch goes up in smoke and Cisco sends you a new one, you got to type the original configuration back into it. So it encrypts it on the screen so you can't see it. You just got to know what it is. So it says enable secret. The number 5 means MD5, which is like a digital signing type of a thing. It takes an arbitrary length thing like our password class and converts it into a 128-bit code, and that's the weird ASCII characters that he tries to interpret the 120-bit code is that you see on the screen. So what that did, in effect, is when I log off of the device and log back in, I'm going to type the command enable. I now have to know that the password is class, so I'll type class. And I've been promoted to the privilege exec mode. Now let's put the command in, which I'll go back to the configuration mode. This command, no IP domain lookup, will prevent the machine from freaking out and hanging up for a moment if you happen to misspell a command. It literally means don't go out and look for a DNS server to look up a command name that you type in because he thinks you're trying to telnet to that device. We have no DNS server present on this lab, so the machine hangs up for a second just looking for it. Okay, now we're going to do what the lawyers at your company told you to say. We used to say, welcome to the computing center, but we can't say that anymore because the hackers went to the court and the judge said, you guys get to go free because it said welcome. It should have said, get out of here, you guys that are not authorized. So I'll type enter, message of the day, and put the, you can use any delimiter character you want to. I'll use the #. just so long as it's not a character that's in the middle of the message, because it'll stop when it receives that. So warning you, whatever your company policy tells you to say. Now what this does is, let me log off again, and before you even attempt to log in, there's the message. It's at the end. It's warning you. You were warned not to log in unless you were properly authorized. Okay, at the top of page 3, and we have a question and answer. Okay, so we're going to verify our settings by moving between modes. And I just did this. I exited out of the machine, and it showed the message that I typed, the warning message of the day. What shortcut keys, the question says, are used to go directly from the global configuration mode to the privilege exec mode? So let me get back to the privilege exec mode. I know it's class. Let me go to the global configuration mode. Now, what shortcut key? I could type exit. I could type end. But my favorite is Control Z, because no matter how far you are, I'll go, for example, I'll say interface VLAN 1. Now I'm config-if. I'm in a sub configuration, global configuration mode. Doesn't matter how deep I've descended into global configuration madness. I wish to get straight back to the privilege exec mode right away, because I need to do a copy, run, start, and save it, maybe. I need to do show IP interface brief and see what's going on. And that key is Control Z. I'm going to hold down the Control key and touch the Z. I'm instantly pop back to the privilege exec mode, and there's our Cisco annoyance that popped up on the screen. I'll just press enter a couple times, get a clear screen. So you could use Control Z. I think Control C also works. Okay, we're supposed to go back to the privilege exec mode again. Okay, he shows me I'll hot top disable to go back to the. And now I'm at the user exec mode, greater than prompt. So what do you have to type to get to the user exec mode, to the privilege exec mode? Enable. I have to know it's class. Password doesn't show on the screen. Now let's put in that IP address, this management address. That's a question at the end of the lab. Why can't I just telnet it to the switch and configure it? I mean, I just that home router that I bought, I just went to a web page and I configured it. Well, industrial strength, heavy duty, enterprise type products don't have built-in web servers to do that stuff. That's for the benefit of home users. These the devices that we're learning how to configure are meant to be in enterprises, and they have a sort of a different philosophy about them. We're going to use a CLI. We're not going to use a GUI to do it. So I need to be in the global configuration mode with the configure terminal. And then I'm going to go say interface. And what are the interfaces that are present here? I can always type interface question mark if I forget how it's spelled or what the word was. And he shows me at the bottom, oh, VLAN. It's VLAN. I want VLAN. Interface. Notice after you type the question mark, built-in context-sensitive help. This is really cool, the CLI context-sensitive help. I type interface and the question mark, and he showed me the list of stuff, and then he reprinted my line for me, interface space, ready for me to type the next part. I type interface over again. I'll type VLAN. And number 1, the default VLAN. You need to give it a management address. And in the text, it says we're supposed to apply the following IP address, 192.168.1.2, and then the subnet mask. And then we need to activate it, just as if it was a real port. Otherwise, it won't be active. The IP address won't be active. Now let's apply a password to the console port. So if someone gets into the data center where the switches are located and they manage to plug into the console port, they won't know what the password is and they won't be able to tamper with it. Only authorized employees, Cisco, that are Cisco technicians and engineers would know the password to do this. So I'm going to type the command line console 0. Prompt changed from config-if. We are no longer working on an interface. We were working on the VLAN interface, the virtual interface, the switch virtual interface, or SVI, the management address for that bigger switch. Now we're actually going to put a password on the console port. So they changed from config-if to config-line, and we're going to type the command password, and we're supposed to use Cisco in Academy. We always use Cisco for the console port. We always use Cisco for the telnet ports, and we always use class for the enable secret password. And then the command login says take that password that I just created and allow people to log in using that password. So it's two lines we got to type. Now we're going to do these exact same 2 lines on the telnet ports, which he calls VTY, means virtual terminal. That's the name that the Unix gearheads, those arrogant, bearded, sandal-footed Unix administrators that Dilbert just wants to slap in the next century, well, those are the guys that wrote the iOS, so that's the command they came up with. So I'll say line VTY 0 through 4, he says here. Same exact command, password, Cisco, and allow logins to take place. Now, before I go to the next page, I've got all the way to the bottom of page 3. I'm going to go ahead and completely log off of this device and show us now all the password protection we have put on this device. Multiple layers of security. We want multiple layers of security to protect what's going on here. So I need to know that the console password is the word Cisco. So I'll type Cisco. And I want to get to the privileged exec mode. I have to know that password's class. In the real world, you should not probably use Cisco in class, because all 10 million students that have ever gone to a Cisco Networking Academy know those. You should probably use something that's a little bit more difficult. Your company that you work for will probably have a password policy. For example, we have a password policy here that your web advisor, my TCC, single sign-on thing has to be 12 characters and has to have an uppercase and a lowercase and a number and stuff like this. Okay, I'm going to go to the top of page 4 and I'm going to configure the address on PCA. I did this already in Packet Tracer as an illustration to our asynchronous remote people who are going to be using Packet Tracer for this. You go into Packet Tracer and you chose that IP configuration on the left-hand portion, and you configure this IP address. But we're going to do it on the honest to God Windows one now. So I'm going to bring up the Windows workstation, and I'm going to double click on the shortcut here to bring up the IP version 4 control panel. I already put the address in there, but let's say you just started your lab here in person, in the in-person lab, up close person lab, and one of the advanced Cisco students had put a weird address in there that didn't belong. The quick and dirty, easy way of getting rid of that is to click the button that says obtain the IP address automatically, which means have the network server, the DHCP IP addressing services server give me an address, and then click use the following IP address, which means put in a static address, and then you can put that address in again. So I'll just put it in again and show you it's supposed to be 192. I didn't have to type the period. It jumped automatically to the next dot. 168. It jumped automatically to the next dot. And let's see, what's our third octet? 1. Uh-oh, it's waiting for the type 2 more digits. How do I get it to jump over to the third octet, to the fourth octet? I can touch the period, or you can click with your mouse. And this workstation is supposed to be 10. Then if I touch tab, he automatically fills in his guess as to what he thinks the subnet mask should be. And here's the world's most popular, single, most numerous subnet mask in the world, the /24.255.255.255.0. Now I must click OK, and I must click the second OK, and I must click the close, all 3 of these, for this to take effect. Now I'm going to type ipconfig just to make sure it's okay. And it looks like it took the address properly, 192.168.1.10. So I completed the steps on the top of the last part, step 3, the top of page 4. And now we're going to check network connectivity. So first of all, we're supposed to go back to S1. Let me bring back S1 term. In Packet Tracer, you would simply click on the picture of the switch and then click the CLI, or you could connect through your PCA, just like we're doing here in the lab, and connect to it using this term-like device. It's a console connection. I'm supposed to type show run. Okay, so show run. Show running-config, but show run works fine. So I did this part before. We can see the enable secret password has been changed. There's a lot of lines in here that are by default. A lot of lines that it doesn't matter whether try to pay attention to them, try not to worry about them. You don't have to configure them. So far in this first page, I did hostname S1, and I did enable secret class. You can see this at the top of the screen. No changes here. But here, interface at the top of the screen, interface VLAN 1, I made its IP address 192.168.1.2. That's going to be the management address of this physical switch. He didn't have that IP address configured before, so there's no way I could ping it or telnet to it or manage it remotely before because he had no IP address. So I had to configure that. Out of the box, he has no layer 3 IP address. And then at the bottom, we see our passwords that we put in. Password Cisco, password Cisco. Do you remember? Did we talk about this command? I think we talked about this in the first 8-week class. How would I slightly hide those passwords from appearing on the screen? What's the secret command for that? Service password encryption. I could type service password encryption, and then all those would have password and have the number 7, which is the code for it's a service password encryption. It's not as strong as MD5, but it keeps some people from looking over your shoulder and see what the passwords are. But he didn't tell us to do that. Okay, now I'm supposed to type show IP interface brief. So show IP interface brief. And we can see very quickly at the top, VLAN 1, 192.168.1.2, status and protocol. I meant to mention this in the lecture Monday, but I did not. Remember the dreaded, feared, and hated OSI 7-layer reference model with 7 layers? And the bottom 2 layers were physical things, the physical and data link layers. So when you use a Cisco device and you're looking at the status of a particular physical thing on it, like in this case, we're looking at that physical 192.168.1.2 address that's been configured on it, so you can ping it, you can telnet to it. Status and protocol are up and up. Now look at all the other ports. They're down and down, except for port number 6. Port number 6 is the wire my PCA VMware is actually bound to an actual physical NIC card, and then NIC card's plugged into port number 6. He's up and up. The first one up is the physical layer. The physical layer is up. The bits are being transferred. 1s and 0s are shooting back and forth across the wire. In fiber optic cable, flashes of light. In Wi-Fi, radio frequency energy. The second one is the data link layer protocol, which in this case is Ethernet. So they're up and up. If you have problems with an interface and it is not on the up and up, there's no way you can do anything with it. It will not ping. You cannot telnet. You cannot transfer data. You must be up and up. So show IP interface brief shows us that everything is up appropriately. And now we're going to test end-to-end connectivity. I'm supposed to go back to the VMware. So here we are back at the command prompt for the post PC. And first of all, I'm supposed to ping my own damn IP address to see if it works. I'll go even further and say, before I ping that address, I'm going to ping the special reserved loopback address to make sure the TCP IP code is properly installed on this device. Okay, so what's the address? 127.0.0.1. Almost every device in the world that's a desktop PC has that address configured. The whole class A 127.anything is reserved for this one test. And it worked. Now I'll do what he says. Ping 192.168.1.10 was my address, and that's proper. Now let's reach out from this PC through the wire, going over to the switch, and see if it's connected to the switch and if we get the answer back from that. Ping 192.168.1.2. Oops. I lost my focus here. Ping 192.168.1.2. So 3 out of 4 worked. The first one failed. Everything is actually totally proper here. We haven't talked this much yet about our address resolution protocol. That's an IP protocol that synchronizes your layer 2 burned in physical MAC address, which normally can't be changed. You have to change a NIC card to change it, to your IP address, which could be anything in the world. You could move your laptop PC to the library and you get a different IP address than if you were in this room. And the ARC cache holds on to that for about 3 minutes. So if I ping again, I don't get that first one failed. So ARP only works for about 3 minutes. The reason being, you could move your laptop to a different floor of an office building or to a different building in a campus, and you would be on some different network. And you should be holding on to that correlation that will only work in the business building. It was proper, but by the time he got to the library, it was improper. He has to forget about it. Okay, hang on just 1 second. Oh, let's rock and roll. Okay. Pope's on line 1. Dalai Lama's holding on 2. Okay, so we pinged at the top of page 7. We pinged the IP address of the switch, and it worked properly. And even on the print of the lab, he shows you that first request timing out, because it's the very first communication that ever took place in the last 3 minutes or more between your PCA and the switch, and it typically times out for the first time. Now, at the bottom here, do not type this thing that says Package Manager. That's for a Windows 7 machine that's never had telnet installed. So I should be able to just type, there's 2 ways to do this. I'm going to do it from the command prompt. Is telnet present? It looks like telnet is present. Okay, so I'm going to type telnet space 192.168.1.2. There's our warning message of the day. Warning you. There's our verification. What's the password? We set the password to be exactly the same as the console port. It should be Cisco. That worked. I should be able to type enable, and I should have to know that it's class. I'm at the privileged exec mode, and we're told it should look something like that. And then we're instructed to save the configuration on the switch. What's our command to save the configuration on the switch? To save the running configuration, which is in RAM, and will evaporate within 1,000th of a second after the power is taken away. I don't care what you saw on CSI Tulsa. It doesn't stay there. You can't spray Freon on it, and the cops can't get back. It's gone within 1,000th of a second. RAM memory must be refreshed 1,000 times every second, or it instantaneously loses its data. So I wish to save that to a flash memory, the NVRAM memory on the device, which is permanent, flash memory, like a flash drive, NVRAM. So I'm going to type copy, run, start, press enter again, and it saves it. Okay, I'm going to do the exact same thing now, but I'm going to use the telnet client graphical client that's built into, in this case, TerraTerm. Now, if I try to use this TerraTerm, common mistake, common boo-boo, uh-oh, whoops, whoopsie, I tried to run TerraTerm inside my VM and connect to the real physical router. It's not connected. There is technically something called USB pass-through, which is supposed to give you the ability in a guest operating machine, like our PCA PCBs, and reach out and physically go out to a real USB port or serial port and go to something. But I haven't turned that on, have not configured this. But in this case, we simply want to do an IP connection. It's going to do that just fine. So I'm going to, I don't want serial. I want a TCP IP connection. And I don't want secure shell. I want telnet. And the host address, 192.168.1.2, that's the destination IP of the switch. So, secure shell is port. We haven't talked that much about TCP yet. We're going to get a whole chapter on it a little later in the course. Telnet's port 23. And secure shell is port 22, but we haven't set up the switch to be a secure shell host. It won't work, but we set it to be a telnet. So I click the telnet button, click OK, and I get the same thing. I get the banner message of the day, and I should know that it's Cisco. I should know it's enable and class, and I can do any command remotely on this device, show IP interface brief, that I could do if I was physically plugged into the console port. So we have tested and verified remote management of the switch from the PC, and they're actually within 3 feet of each other here, but they could be miles and miles, anywhere you have IP connectivity. Okay, so what's this last question here? Why must you use a console connection to initially configure the switch? Why can't I just tell that it's secure shell right into the switch? A factory fresh unconfigured switch. Well, I can't because he has no IP address. It's not been specified yet. I had to go in there and do interface VLAN 1 and put in the IP address and then in the shutdown command to energize that layer 3 management address on that layer 2 switch for it to do something. Okay, I've completed all the objectives of the lab, and now what I should do, since I don't want to get the advanced Cisco guys mad at me at my lab workstation, because they, like they said about the intelligence services, have 7 different ways from Sunday of getting back at you. Don't get them mad at you. So what I'm going to do is I'm going to actually go to the real console port here. And now if I do a show start, it's there. I saved it. I remember host name, S1, password, Cisco, no secret class, all that stuff's on here. So what should I do to get rid of this? I'm going to make that VLAN show up on purpose. I'm going to intentionally, this is beyond the scope of today's lab, but just to show you what you might see when you run into a switch that somebody else forgot to erase, what you might have to deal with to get that switch back in the normal proper operating condition. Before you start your lab, it should be totally initialized and fresh. It should have any previous dregs of any previous configuration on there. It could hose your lab and make it not work, particularly VLANs. When you're trying to ping between two ports and they're different VLANs, and you didn't know that, it would never work. So I'm going to go to the configuration mode. I'm going to say VLAN 2. I'm just going to create a VLAN. Now notice when I do the dir command, there's a new file there, vlan.dat. I departed from the default factory fresh, unconfigured switch. Most of these switches that ship in the world are never get configured. They just want to be a fast switch in one network. And the vlan.dat file is there. Well, if you encountered this when you did a switch and you encountered when you did show start, there's something on there. You need to reset the switch before you try to use it in your lab. So I'm going to do, first of all, I'm going to erase the vlan.dat file. I'm going to type delete vlan.dat. I have to press enter 3 times. Okay, so if I do a dir again, I'm out. And then I'm going to erase the startup configuration file. Erase, start or start. This command is so dangerous that you're not allowed to abbreviate it and just press enter, because you're deleting the entire configuration and hosting the entire switch. So you must spell it out completely. Well, let's use tab completion. So I'll type erase star, I'll touch the tab key. It's now completely spelled out. I'll press enter and I have to do it. Since it's so dangerous, you have to press enter twice. Now, I have to reload the printer. I'm sorry, reload the switch. Warning, Will Robinson. This is like Microsoft Word. He's saying, you're going to reload the device. When you quit Microsoft Word and you haven't saved your document yet, Microsoft Word pops up a little helpful thing on the screen that says, what an idiot you are. He doesn't say that. He says, don't you want to click yes and save the document and then let me exit the Word document for you so that these hours of work you typed in your dissertation are not lost forever? And oh yeah, that's right. I forgot to save it. You can save it. So what this is telling us, the Cisco switch is telling us, and the router does the same thing. You have put some configuration on this device and you're telling me to reload the device and you haven't saved it. Don't you want to save it? If I answered yes right now, it would pop it right back up and everything I did with the erase start would be reversed. So I wish to say, no, do not save it. Reboot as a fresh device. Excuse me. And we'll let it restart. And this is like watching grass grow or watching paint dry. The exact same startup procedure as a desktop PC would do. If he loaded Windows, he would do the power on self-test, count the RAM, load the Windows files from the hard disk drive, boot Windows. Windows would then load the Windows registry, put in your preferred desktop background color, your icons, arrange what you like, and then you'll be able to click and use Windows. So Cisco routers and switches do the same thing. They do a power on self-test, make sure all the smoke hasn't gotten out. Then they load the iOS from flash memory, and then they put it in RAM memory and they execute it from RAM. Windows does the same thing. He loads the files from the hard drive, puts it in RAM. RAM memory is 1,000 times faster than hard drives, 10,000 times faster than flash memory. So now the switch is loading the lines of code for the switch-based iOS out of flash memory into the RAM. And then he's going to run it from RAM, and you'll see him boot up in a minute now, and he'll be ready to actually execute whatever code you wanted to do. And we should be able to, this time, we should be able to get to see him ask the question, do you want to do the automatic configuration dialog? And I'll show you there again what happens if you accidentally answer yes instead of no. You should say no. So this is kind of like watching Linux boot up. You get a bunch of lines that flow above the screen. And then go off the top of the screen. And you're using an old version of hyperterminal and you try to scroll back and everything's corrupted. You can type that command show version. And it'll bring all the stuff back on the screen where you can see what's the serial number. What version of iOS is it? What is the interface port numbering scheme? Things of that nature. So we can see we're running iOS version 15.2 for the switches, which is the recommended level that we use in the Cisco Networking Academy. LAN base, K9. K9 is the code that the iOS supports encryption. We could do secure shell. Secure shell requires encryption, public-private key. Now let's see here if he does what I predicted he would do. And in the second, he ought to be able to pop up on the screen something about, do you want to go into the automatic setup dialog and set the passwords and things of that nature. Okay, there's our system configuration dialog warning us. Do you want to go into the initial configuration dialog? So what if I accidentally answered yes here? I'll say yes. Oh, and now he's asking me, management setup, simple network management protocol? What? What? Basic setup, extended setup? What am I supposed to do here? To get out of this thing you accidentally got into, just type the Control-C sequence, and you will go right back as if you'd answered no. Otherwise, it's going to ask you 20 or 30 questions about management protocols. Okay, there we go. We completed that. Hang loose. I'm going to stop the tape from rolling.